Hi y'all, in this lab we were asked to observe an object in motion at a constant velocity and then use a tracking software to determine the values of the object's position and velocity. We then needed to compare this to a computer simulated model of an object at constant velocity, which would represent perfect conditions with no outside interactions. This lab required me to use my understanding of physics and motion to calculate the velocity of the ball at different time points and compare and contrast a real-world experiment to a computer-generated program which would represent perfect conditions. In a second, you will see a tennis ball roll across my kitchen table. As you can see, the ball rolls into and out of the frame at relatively the same speed. But if you can't trust your eyes, let's look at the data. Using Tracker, I track the ball's movement in order to obtain the ball's position at different time increments. Tracker is great because they give you both the x and the y components of the position vector, but because we can tell that the ball is rolling flat on the table, we are only really interested in looking at the x component of the position. So, I took that x component of the position along with the associated time variables, did some math, and figured out the velocity. As you can see, the position versus time graph, the slope is relatively constant, which by definition means that the average velocity should also be constant, as we now know that the average velocity is defined by the change in position divided by the change in time. And after looking at our graph, we can see that the velocity doesn't really change that much throughout the movement. But there are a few small differences, which could be accounted for me possibly not tracking the ball as precisely as possible, or possibly I didn't clean my table well enough and there was some friction acting on the tennis ball at certain moments. I then used some starter code and made sure that I added my initial conditions as well as what I found to be the average velocity in my trial and the time increments to get a model of what the tennis ball's movement and velocity would have been like under perfect conditions. After looking at the 3D model, I can say that this is what the ball movement looked like, and the position versus time graph also looks pretty similar to the graph that I generated using Tracker. Let's look at a graph of the position functions together. As you can see, they look pretty similar, but the one generated by the computer is completely constant, whereas the one made with the data from Tracker has a few jumps in it, again, likely due to my tracking ability in Tracker, but also because it was not a perfect system and had outside forces working on the ball, one possibly being friction. If I were to flip my axes in Tracker, as I almost did because I didn't know how to rotate the video at first, the velocity I found would have remained the same, but it would have been in the y direction rather than the x direction. The only thing that changed was the direction the ball is moving as compared to the axes, but the magnitude of the velocity would have remained the same. If we were to try to look at all of the forces acting on the ball that add up to a zero net force, we can tell that there is some gravity acting on the ball, but there are no other real visible forces. There's got to be the force of the table holding the ball up, the force of gravity, possibly some friction, but who's to say there's not a vent pushing the ball forward or backwards, or some kind of airflow, some small force. But if the velocity really was constant, then we can say that there was a zero net force on the ball.